Common mistakes and design alternatives in concurrent task tree. The use of task models in user interface design and development has recently been recognized as an important contribution to obtain more user-oriented interactive applications. Hello, my name is Manipur Rahman and I'm going to discuss about problems and their alternatives in concurrent task tree. But before going to that part, I would like to discuss a little about what is concurrent task tree. The design and systematic development of usable user interface is becoming increasingly important. The use of task model is considered to be the main approach for the specification of the presentation trial in interactive applications. There are main features of concurrent task tree. First one is focus on activities that allow designers to concentrate on the activities that user aim to perform that are the most relevant aspect when designing interactive application that encompass both user and system related aspect, avoiding low level implementation details that at the beginning stage would only be obscure the decision to take. Then hierarchical structure is something very initiative. In fact, often when people have to solve a problem, they tend to decompose it into smaller problems, still maintaining the relationship between the various part of the solution. The hierarchical structure of this specification has two advantages. It provides a wide range of granularity, allowing large and small task structures to be reused. Object and task attribute feature deal with the tasks that are identified. It is important to indicate the objects that have to be manipulated to support their performance. Two broad type of objects can be considered: the user interface object and the application domain object. Multiple user interface object can be associated to a domain object. For example, temperature can be represented by a bar chart of actual value. Now, let's have a detail about some mistake. The need to specify which component of the interactive system considered will perform the task, like for example, ambiguity, new operator for a compact specification of common situations, the necessity to define better the relationship between a father task and its subtask, additional information about the task that could be used in the user interface development, and new operator for a compact specification of common situations. If we talk about the ambiguity problem, like if we simply build a task model using the different operators, the first problem is possible ambiguity expression. Like in this picture, we have T, T1, T2, and T3. T1 and T2 have twice, T2 and T3 interleaving each other. But the problem is same. To solve the ambiguity problem, we have two possibilities. We also write these two combination, although it's not clear in the writing, but in the next picture you can see the possibilities. Or we can use the priority order among operator defined in the standard lotus, like we have choice, parallel composition, disabling, enabling, or we can reduce a task which de-ambiguous the expression. Parallel composition can be either completely interleaving among tasks or interleaving with synchronization on some actions. If we talk about the problem between relationship between further task and its subtasks, if we use this operator in a hierarchical context, we can achieve a lot of flexibility in terms of being able to specify different behaviors. For example, in the next diagram, there are two possibilities. The same tasks are involved T1 and T2 are performed interleaving in both cases, but if the iteration is at the further level, then we mean order independence performers. Tasks can be executed in any order, but before executing them again, both tasks have to be terminated. The solution in the second case with iteration reduced at the subtask level. We have a continuous interleaving among tasks, which means that once one task is terminated, it can be executed again without waiting for the termination of the other task. An example of order independence is when specifying a request for a flight database, then user have to satisfy both departure and arrival times, but the order is not meaningful. Once the request is transmitted, then a new one can be composed in the same way. In the same application, we have continuous interleaving between the task specifying a request and the one cleaning it. The difference between iterative and recursive specification in concurrent task is that in the first case, when we use the iterative operator, the performance of the related task is repeated in the same modalities until another task deactivates it. The second case, when in the definition of a task we find the task itself again, allow us to describe the cases when the depending and some condition. In our example, the selection which activate a new order form, we want to perform a task again without knowing in advance how many times we will perform it, and for each new performance we will give the possibility to perform a new additional task. In our example, editing a new form in the task tree, it is sufficient to specify the possible recursion at only one level to indicate that it may happen more than once. In our example, the user can stop the recursion by selecting the edit and close task. If we talk about between the iteration and a choice, in this picture, make sure that the user has to choose from have an iteration task to start with. Otherwise, the user interface will never stop. In this picture, we have to access the museum. User has to access the museum through login process, but iteration will never stop. For that, we are going to add a user interaction task. And the next example is same for the course registration. With this type of process, only one course can be registered by the program. So for the possible solution is make register course an iterative task. A little more example about this. In this example, we have a route, and this route has three tasks: task 0, task 1, task 2, and task 3. Task 0 will never stop, therefore task 3 is never enabled. So we have to add a user interaction with deactivation task. If you talk about the task model make sure that the task the user has to choose from an interaction task to start with. The same task can be modeled in different ways, and each model may result in a quite different user interface. If we want to manipulate an object in two different ways, first one is object action style, the second one is action object style. In this picture, you can remove, edit, and move object in the first part using enabling with information exchange and with the choice of remove, edit, or move. But the problem is that you have to terminate the one task to do the other one. But in the second part, we solve this problem. We add some more subtasks using choice operator like remove object, edit object, and then move object. They have two subtasks: select object and remove with the deactivation task. Like if you want to do one task, you don't have to deactivate it. For the granularity of the task recomposition, when to stop refining the task model, is also a problem that we face in concurrent task tree. For the alternative for that is we have to clear up the uncertainty of granularity issue. We have defined that the basic data elements must be reached during the task decomposition. If we talk about the burden of repeated modeling, frequent and structurally similar interactions problem, the solution for that problem is, even though the formal requirement seems to worsen the task model size, we propose the identification of structural task patterns that are common in the interaction of user and an information system. The next possible common mistake is the interactability of the task models for large business management information system, even with the aid of available tool. So the solution, or you can say that the design alternative for that, is the user can introduce a tool that support this work style by allowing the reuse of the structural pattern and their adjustment to each usage. If you talk about the notorious but frequent overlooked difference between modeling an itinerary across the interface and modeling the interface itself, we consider the task model to be an assemblage of task pattern. By adding some recurrent building rules, we are defining a grammar that allows both modeling user interaction in a very economic way and modeling the interface, since the task model will represent the itinerary through the whole interface. We also face the difficulty of defining how this task model should drive later models of the system.